Assalamu alaikum. So, as Mr. Mohsen said, today I'll be talking about a project assigned to us by him. I worked on it, me and my friend Mohammed Harash. It is kind of a snakes and scorpions tracker. So, the idea behind this the project is that in Morocco, these kind of venomous creatures, especially these two, snakes and scorpions, are becoming more and more of a problem to the people here, especially in villages and remote areas. As according to the Anti-Poison and Pharmacovigilance Center in Morocco, there are nearly 30,000 cases of scorpion stings happening every year in Morocco and about 350 snake bites. 70% of these cases are among elderly people and children under the age of 15, and several hundreds of these cases lead to death. There is also another problem, which is the distance between these villages and the nearest hospital to them, because this distance may go up to 15 kilometers at least, with no means to go there. Or in some cases, when we do get to the hospital, if we get there in time, we found that it might lack the anti-venom or antidote to treat the cases. So our project is like this. We decided to install some cameras that will take pictures and send them to a treatment system that will classify by night or day. It will take the pictures. It will send them to. It will send them to our treatment system, which will decide if the picture is of a snake or a scorpion, and then we'll send the information to a mobile phone, or in the best case, and what we're hoping for, to a robot that will neutralize these creatures. So we're still working on this project. It's still not completed yet. So we'll be talking about the image processing part here today using artificial intelligence. So we'll start with some notion of artificial intelligence that probably everyone knows here. What is artificial intelligence, machine learning, and deep learning? So artificial intelligence is a way to mimic or recreate human intelligence in machines. The machine learning is using algorithms and mathematical processes to create this intelligence, and the deep learning is kind of a more powerful version of machine learning. It is technically it's the same as machine learning. It's just using more layers to treat the images and the problems. Different learning processes in machine learning and deep learning. There is the supervised learning, which uses labeled and structured data to train our models. There is unsupervised learning, which uses unlabeled data to train the models. So in this case, our model only group our data to separate our data to different groups, depending on the features, they are similarities between the images. And there is reinforcement learning, which uses trials and errors to train the model. For example, we can take the AlphaZero or Stockfish, the two machines that learn to play chess. They are using reinforcement learning to create. So the supervised learning is divided into two problems. They can solve two problems: classification problems and regression problems. Classification problems, which we'll be using here in our project, it is used to classify things. It is normally its result is a discrete variable, and there is the regression problems, the problems which use continuous variables and are used normally to predict not predict. They are used to decide on new data based on the previous data they learned from. Here they are the algorithms of the deep learning and artificial neural network. They are artificial neural network. They are inspired from the biological architecture of human brains. So they are kind of trying to recreate human brains. recurrent neural network is a form of artificial neural network. It is normally used in dealing with sequential data, and is used to predict for prediction systems. And there is the convolutional neural network, which is used for mostly processing images. This is the basic structure of a deep neural network. There is an input layer which has our input values, an output layer which has our output values, and hidden layers between them. So the more hidden layers we have in our model, the more accurate it will be, but also it will need more requirement for hardware to use it. So each layer is composed of a number of nodes. These nodes are each connected between each other with weights, and to calculate the value of each node, we calculate the weighted sum plus a bias that is in every node. Every node has a bias. So we calculate the weighted sum plus a bias, and we feed it to an activation function. These activation functions are normally used to introduce non-linearity into our system. So once we calculate all, in the beginning, these weights are random values between 0 and 1. So in the first time when we first create our model, we give it an input. We train it using the supervised learning. So we give it labeled data and structured data to learn from it. So it uses the forward propagation to calculate the value of the output layers, and then we compare these values to the values that should be to the predicted values that should be there. We calculate an error between the calculated values and the predicted values, and we extract a cost function, which is the mean square error between all these errors, and this cost function, we try to find the minimum of this cost function to minimize the error. Because if we found the minimum of the cost function, that means that we found the minimum error possible of our model. To do that, we use the back propagation and the gradient descent methods to do the back propagation and adjust the weights and the biases of our system, of our model. And like that, we have a chain model. So the practical side of our project is we'll take a picture of a scorpion or a snake. First, it will pass by a convolutional neural network, which will help us decide on some features, edges or curves or something like that. And then we use the pooling. There is first the convolution part, which will help us decide the edges and the curves and stuff like that. And there is the pooling part, which will reduce the matrix. And then in the end, there is the flattening part, which turns the matrix into a vector, which is then fed to the artificial neural network or the deep neural network, which will treat it and give us the results. This is the data set we trained our model on. We gave it a bunch of images of snakes and scorpions, and it trained on it. It trained using the stochastic gradient descent. It is an algorithm used in deep learning. So this is the error and the accuracy of our system after training it. We see that in the beginning the loss was so big and the accuracy of the system was so small, 0.437. In the end, the accuracy has gone to 98%. So we were able to train our system our model to 98% in the end. These are just some examples of the results we get when we use our model. And now we talk about the software used doing this project. We start by Python. Of course, there are a lot of languages we can use to program in artificial intelligence, but the one that still leads the pack is Python, because it has some support, some community support and pre-built libraries like NumPy, Pandas, and FST that helps expedite artificial intelligence development. There is the TensorFlow, which is an open source software library for data flow and differential programming across a range of tasks. It is also used in machine learning applications such as neural network. It is used for both researches and productions at Google. There is Keras. It is also an open source neural network library written in Python. It is capable of running on top of TensorFlow. It is designed to enable fast experimentation with deep neural networks. And there is NumPy. NumPy is a library for Python. It's a library in Python, which is used to calculate multidimensional arrays and matrix. And thanks for your attention.